Okay, we continue with the International A-Level Statistics S2 paper from January 2024, and this is question number 7. A continuous random variable x has cumulative distribution function f of x given by the following formula, where a, b, and k are non-zero constants. Given that the mode of x is 1.5, part A, show that b equals 3. So we know that the mode is the value of x where the PDF lowercase f of x is a maximum. So we need to work out the PDF f of x, and we know that the PDF is the derivative of CDF. So we differentiate the CDF and we'll get k brackets, since we have this formula for the CDF. When we differentiate it, we'll get k brackets a plus 3b x squared minus 4x cubed. And we are told that the mode is at x equals 1.5. Therefore, the PDF f of x has a maximum at x equals 1.5. So that means that f dash of x is going to be equal to 0 at x equals 1.5. So that means that we need to differentiate the PDF, and we get from this formula, this is the PDF, and when we differentiate it, we'll get k brackets 6bx minus 12x squared. So then we know that at x equals 1.5, f dash of x is equal to 0. So when x equals 1.5, f dash of x is equal to 0. So we substitute x equals 1.5 into the formula for f dash, and we get k brackets 6b times 1.5 minus 12 1.5 squared, and that's equal to 0. So we solve this equation and we find the value of b. So here we get that obviously k is non-zero, as the question says. K is a non-zero constant. Therefore, we have that 6b times 1.5 minus 12 times 1.5 squared is going to be equal to 0. So that tells us that we have 6 times 1.5 is 9b minus 12 times 1.5 squared, which is 27, equals 0. So from here, 9b is going to be equal to 27, and that gives us b equals 27 divided by 9 equals 3. And that's what the question wanted us to show. Part B. Hence, show that a equals 2. In order to find the value of a, now that we know b equals 3, in order to find the value of a, we go to the expression for the CDF, and we know that the CDF, capital F of 1 is equal to 0 from here. Yep. That corresponds to 0. So we have that f of 1 equals 0. So Actually 1 is in, let's go back here, 1 is included in there. So f of 1, we use the expression for f, and we have k brackets, so a, instead of x we write 1, and we have bx cubed, so we have b is 3, x is 1 cubed, minus x to the power 4, so we have 1 to the power 4, and then finally minus 4, and that's going to be equal to 0. So again, k is non-zero, therefore only the expression inside brackets is going to be equal to 0. So we get a times 1, which is a, plus 3 times 1 cubed, which is 3, minus 1 to the power 4, which is 1, and minus 4 equals 0. So 3 minus 1 minus 4 is minus 2, so a minus 2 equals 0, and that gives us a equals 2 as the question wanted us to show. Part C. Show that the median of x lies between 1.4 and 1.5. So we know that the median m is the value where the CDF capital F is equal to 0.5. So the median m is the value where the CDF evaluated at m is 0.5. We know that, so we know that A is 2 from part B, B equals 3 from part A, and also from the expression for f of x, we know that f of 2 is 1 from here. F of 2 is 1. So we're going to use these facts in order to find the value of k. So the expression for the CDF is k brackets, and we substitute these values of a and b into the formula along with the value of 2 for x. So we get k brackets 2 times 2 plus 3 times, we can write brackets, so it's 3 times 2 cubed minus 2 to the power 4 minus 4 equals 1. So 2 times 2 plus 3 times 2 cubed minus 2 to the power 4 minus 4 gives us 8, and it's times k, that equals 1. Therefore, k is going to be 1/8. So the expression for f of x is going to be 1/8 brackets 2x plus 3x cubed minus x to the power 4 minus 4. Now, we want to show that the median lies between 1.4 and 1.5. So it's enough to evaluate the CDF F, capital F, at 1.4 and 1.5, and show that 0.5 lies between the answers that we get. So let's do that. So we evaluate f of 1.4, we get 1 over 8, 2 times 1.4 plus 3 times 1.4 cubed minus 1.4 to the power 4 minus 4. Plugging this into our calculator, we'll get 0.3988. Then we evaluate f of 1.5. We get 1 over 8, 2 brackets 1.5 plus 3 times 1.5 cubed minus 1.5 to the power 4 minus 4, and from calculator we get 0.5078. So we notice that 0.5 lies in between the values that we've obtained, 0.3988 and 0.5078. So we conclude that the median lies between 1.4 and 1.5, as the question wanted us to show.